series that we started 3 iterations ago. So the first presentation was by Dr. Brutzman, and he talked about robots and drones and how that had evolved in the Russo-Ukrainian War. And then we were fortunate to have Dr. Chris Paul, who talked about deception and decoys and how those were being used by both sides in that war. And then John Hammerer presented a presentation, that sounds weird, on integrated air and missile defense and the use of missiles in Ukraine, and again, by both sides. And adaptation and evolution as the two sides competed with each other in the Russo-Ukrainian War. And so for today's presentation, we are grateful to have Dr. Wenschel Lan from the Space Systems Academic Group. And Dr. Lan is going to talk about the use of commercial space and the adaptation and evolution of the use of space during the conflict. So with that, this will be our last presentation before we break for the holidays. And then we have one more presentation, which will probably be in mid-February, and that is electronic warfare. And so I am right now the last man standing to present that, so don't let that deter you from coming to it. But if people have topics that they would like addressed or have part of a presentation they would like to deliver, either faculty or students, please let me know, and I'd be happy to roll you into that offering.
Colonel, if I may.
Yes, please.
So, as he's saying, these are the innovation in the war in Ukraine. We do have another Seapower conversation that will be taking place on the 11th of January. That one is going to be presented regarding questioning the carrier. So outside of this stream that we're doing here with Ukraine War. Thanks so much.
Great. Thanks, Rex. Do you want this?
Yeah, I'll use it.
You stand there? Okay.
Yeah.
Great. Let me make sure when I turn it off, it still works.
Okay. Thanks, Randy, for the introduction. Yep. And I've actually also invited 2 of our Space Systems students, Lieutenant Austin Dumas and Lieutenant Forrest Hansen, to talk about their research, particularly in Starlink, and how that can be used for future conflicts as well. So it's a group effort today. So just to start off, commercial space actually isn't super new. DirecTV has been used for decades, for example. But what is new is the fact that in the last 10 years that we've had this massive exponential growth in the amount of commercially available data we have. And that comes with the mega constellations that have been launched since about 2013, providing that level of data at the unclassified level, right, which is huge. And so the example that I'm showing here just shows the quality and coverage of those types of sensors that we have on orbit right now. And this comes from Planet Labs, which was first, like I said, launched in 2013. And since then, they have almost 180 or more satellites in that constellation. And so the resolution that you get from this commercial imagery is shown right here. So even before the conflict, this was available. And the picture on the left shows a region at the northern Ukrainian border with Russia. And you can see that there's not a whole lot here, right, even with this resolution. But then and this was in October of 2021, so about 4 months before the invasion. Then we fast forward just 2 months, not even a full 2 months. And the difference here, you can see that, yes, there is a lot more snow, but also that there are a lot more buildings and infrastructure and vehicles. So even at this resolution, we can see that there's obvious evidence of military buildup. And this is just an example of the type of data that's available at, in huge amounts. And so just to give people an idea of how much data is really being downloaded from these constellations, I've shown 2 different constellations. So Worldview 2, Worldview 3, they're built by Maxar, and they were launched, I think, in 2009, starting 2009. And there's only 2 satellites in this fleet, but they take really good pictures, right? But then Planet, when they started launching satellites, this is just a subset of those satellites. But if you look at the coverage over Ukraine, they're getting a data set every hour and a half or so. And then maybe a little bit less, right? But then with Planet, you're getting at least 5 sources of data at a given time, and that refresh rate is on the order of minutes. So what that translates to on a data perspective is that there's a terabyte of data per satellite coming down per day. that they're downloading. So you multiply that by 200 or so satellites, and you have hundreds of terabytes of data coming down per day over certain areas. And so that's the scale that we're talking about. And so when you look at small satellites and how small are they, right? So the Planet Flock satellites are tiny, and this is the size that it's at. So for those online, if you look at the camera, this is a 3U CubeSat, and I'll just lift it for those in the room. So about the size of a shoebox, and maybe only a single shoe. And the camera that is in here essentially can take the pictures at this resolution that I showed at the very beginning, right? And then, so compared to a really large satellite, which is now the size of a school bus, you get 10 times the resolution with a bigger satellite, but not as much data. So that's the trade-off and the scale of which this data is being produced at. And so when you extend this capability across multiple constellations of hundreds of satellites, this is just an enormous amount of data that we have to work with and is available, again, at the unclassified level, right, which is important. So what the advantage that I gave to you that has given to Ukraine is this asymmetric advantage in the conflict. And because there's this, the data is available to a country that doesn't even have its own spacecraft, right? Typically how this works is a country builds a satellite, it launches it, and that's how it gets its data. Now a country that doesn't have that capability has this massive amount of data available to them, and that gives an advantage to them from an information perspective. On the other hand, Russia was sanctioned, as we all know, and this puts them at an even more disadvantage because not just from a funding perspective and a lack of supplies, but they basically don't have access to this information. So that also gives an asymmetric advantage to Ukraine in this conflict. Okay, so then what do we do with this data and how does that affect the general public? So as we know with conflicts in different countries, the conflict is actually portrayed very differently, and certainly so in this case between how Russia has portrayed it and how Ukraine has. And so for the general public, sometimes the data is not available to really get to that ground truth. But in this case, because the commercial data was available to everybody, not just the folks that were in that region, but globally, this then provides transparency into the conflict for everyone around the world. So an example of this is when Russia claimed at near the beginning of the invasion that they were not responsible for civilian deaths. But when you use this satellite imagery and correlate it with footage that was taken on the ground, you can very clearly see that, nope, they were wrong. And so using this type of data, and now it's available to everybody, can then disprove this false propaganda that is being put out there. And then again, providing transparency into the conflict. Okay. And so I've talked a lot about pictures so far, but it's not just pictures that are being collected. I think people connect to that because it's a picture taken by a camera, so that makes sense. But there's actually a lot of other data that's being collected. And so one example of that is ship tracking data. And so there's a company called Spire Global. They're actually up in the Bay Area, and they have 160 satellites now on orbit. And one of the data products they collect is AIS ship tracking data. And so this video is something that they put together, and the time frame is that it starts a week before the invasion and then goes, I think, a week or two past. And they focused on the Black Sea. And what you can see here is that at the beginning of the conflict, it's pretty vibrant. There's ships moving around and stuff is happening. And then you fast forward to later and it's not so active. And that's just by tracking its location and speed and things like that. But that's the only information that's being displayed here for visual purposes. But there's actually data associated with the ship tracking, with the information that comes down with the location as well. And that includes country of origin, the type of cargo, and the class of ship. And so when you start to layer all these pieces of data together, then you actually get a bigger picture, and you actually can, with the right data analytic tools and everything, and the insight into how that conflict is affecting other regions, or that region itself, but in other factors that play into that conflict. And so two examples I'm showing here using commercially available space data. The one on the left is the country of origin, showing who was actually still receiving was still receiving oil from Russia, right? And at the beginning, that was an important factor. And then on the right, fast forward to actually, I think August of this year, the layering the type of ship and the cargo that it's carrying then paints a picture of how Ukraine is actually able to export their grain, even though that the ports are blocked. So just an example of how commercial data, not just with pictures, is being used in the conflict to add information and awareness of the situation. So it's great to have all this data, but you can't share with anybody. It's kind of a moot point. So one of the key takeaways from this conflict is the fact that we were able to share this data, and it's because it was unclassified. And the U.S. intelligence community actually took credit for coordinating the release of this data with coordinating with private firms to coordinate to release the data to friendly nations, which then gave Ukraine that information advantage, which, as we have seen, has played a big part in that conflict. And then this image here is just another example of something that can be taken from space and is commercially available. And you can tell that the resolution is better in this picture. It comes from one of the bigger satellites. And so, and it's actually not even taken overhead. It's at an angle, which gives you that depth perception, right, of the situation. But then you can actually individually count exactly how many cars are in that convoy headed towards Kiev. And again, this is just, you can go look it up or buy it. And so with the commercial space industry, we gained a lot of flexibility because, as we all know, the government is not afforded that luxury a lot of the time. And so not just on the satellite, on the space segment of the space industry, but on the launch segment as well. I think, the launch segment is now mostly controlled by and dominated by the commercial sector, as demonstrated by SpaceX. But other companies such as Rocket Lab are also very successful. And in this case, Black Sky, which is another satellite imagery company, they were working with Rocket Lab. And as a response to the invasion, which, end of February, they said, hey, let's just change the orbit inclination so we get better coverage of Ukraine and Russia. And Rocket Lab was like, all right. So, a month later, and they already had this launch scheduled a month after the conflict had already started. And they said, well, let's go for it. And they were actually able to do that. And so that's, for those of you that may not be familiar with the launch industry, this is a really big deal to be able to change your orbit parameters a month before you actually go. The joke is that you can't launch until the amount of paper you have weighs as much as the launch vehicle, right? So just to kind of highlight how much work goes into that. So this is a big deal, but just to highlight how commercial space, that flexibility plays into the calculus of what we can do with it. And then with flexibility comes resiliency, and Austin and Forrest will talk about this a little bit more. But within days of the invasion, Starlink said, here, just have a bunch of terminals. And depending on what source you look at, I found some sources that says, well, hundreds of terminals. And I went on to the Ukrainian news and it said thousands of terminals, 10,000. So it's probably somewhere in between there. But the fact that they were able to do that is a game changer. And because of that resiliency, and I'll talk about a little bit more of that, as to what those vulnerabilities were, it changes the deterrence calculus, as you see in this quote here. The SATCOM piece of it, although it's not, the commercial imagery, is also a very big player, and I think one of the most famous examples of how it can be used in conflict. Okay, so then, I've talked a lot about how commercial space is great, but there's several vulnerabilities associated with this as well. So the two that I'm going to highlight today, the first one being that commercial companies can choose just not to participate, and we saw that Elon Musk basically did that, right? He said, nah, I'm good, don't do that. So that's a vulnerability, and then there's mechanisms that I think are being pursued to avoid that. And then the other piece is that space assets are targets, and when we are starting to use commercial assets for military purposes, then that changes the view on what are considered legitimate targets. And what's significant is that Russia then came out and said this at a UN working group meeting and said, hey, we're going to consider these legitimate targets now. And actually turns out after they already attacked them. So, so those are significant vulnerabilities that we still have to contend with. And so when Russia said, hey, these are legitimate targets, what do they mean? What are they actually going to do? And so there's literature out there that shows like, you know, how Russia approaches this problem. And so there's essentially two categories of effects. They can either do cyber or electronic warfare type attack, or a physical one, which means essentially shooting down the satellite. Generally, shooting down a satellite is frowned upon by most people and creates more problems than it solves typically. So there is a deterrence factor that basically they haven't used it in this conflict. And so I'm going to focus just real quick on cyber and electronic warfare. So one of the examples of a cyber attack was when Russia hacked into Viasat a day before they invaded, and it knocked out tens of thousands of modems, and that was the malware attack. And then they went ahead and flooded the servers to create a denial of service attack. And then the response that Viasat had, the solution, the only thing they could do is because the attacks were done against the ground modems, they had to then replace tens of thousands of modems to get those people back online. So while they were still able to maintain that service for people who weren't knocked out, that's tens of thousands of modems that they had to replace. So then contrasted with Starlink, of course, you know, once Ukraine started using Starlink, Russia said, we're going after that one too. And so there are reports of, you know, jamming and cyber attacks. And Starlink's solution, because the effect was on the space segment, they were able to upload a software update for the entire fleet of Starlink satellites. This is 4,000 plus satellites that they were able to then protect within a day of the reported jamming. So this adaptability and the ability to respond quickly was highlighted by the director of EW at OSD, who said, hey, like we need to be able to do this going forward. And that's a very important piece and lesson learned from using commercial assets. Last electronic warfare effect I want to just touch on is the use of GPS jamming. I think this is, you know, at least for the space folks here, you know, this was actually, you know, the availability of alternate position navigation timing sources is a very big deal right now. And so the fact that Russia was using it was significant as well. At the beginning, they didn't need to. Right, so this data that's being shown here is from an open source website called gpsjam.org, and they've collected all of the interference reports from all the aircraft that are flying all over the world. So if you go to this website, you can actually look at where GPS jamming is, starting, I think, back from February of 2022 all the way until now. And so so the green regions show that there's not there's very little, 0 to 2% interference, and if there's no color, it means that there's no data. So turns out nobody wants to fly over a region of conflict. So, so at the beginning of the war in April, right, 2 months after the invasion, not a whole lot of jamming. But if we fast forward to August of this year, where Ukraine was increasing their drone attacks on Moscow, now you can see that it's pretty lit up. There's red all over Moscow too, and you know the threshold is 10%. But just to show that there's a very big contrast between, you know, they were obviously jamming when the drones are coming into Moscow. So, I have touched on a few different ways that commercial space has been used in the conflict. But I think what's important to talk about is how are we going to use it going forward, right? It's great that it was useful and everything, but how we're going to address those vulnerabilities and create that resiliency going forward. So I'm going to turn it over to the students, and Lieutenant Austin Dumas is going to go first, and they're going to talk about the research they're doing to solve those kinds of problems. So Austin, I'll drive for you, and Austin is calling in. So.
Awesome. Yeah. Hey, can you hear me all right, Wenschel?
Yeah. Hold on. You're kind of quiet. I think that's as far as it goes. All right, go ahead.
A little bit better?
Yeah.
All right, awesome. Hey, good afternoon, everybody. Lieutenant Austin Dumas. I'm in the Space Systems Academic Group. I'm here in 366 and 591 curriculums, an NSW officer by trade. And this conflict is really where my operational focus was prior to coming here to MPS. So a lot of times we think about the conflict in Ukraine, think about tanks, think about guys in trenches, think about a lot of different things, but really the big part of this war is being fought on the electromagnetic spectrum. And so it's constantly a cat and mouse game of radio signals being jammed, countering that, and a lot of this is playing out in the electronic warfare spectrum. So, additionally, most have probably seen a lot of the articles and news, and everyone that's been following it, the drone warfare, and really the asymmetric strategic impacts that has, and has been able to have. So, with that, there is Wenschel just talked a lot about the cyber attacks, the jamming environment, and so it makes it extremely hard to actually be able to command and control these assets. Data links are unlikely to work, and even if even when you are able to get to the work, for the line of sight connections, having to have an operator within line of sight of that asset increases the vulnerability just because of the given detection capability on the RF spectrum. You can see on the bottom left, you have Ukrainian soft personnel launching a Switchblade, which is a loitering munition. Think of like an unmanned aerial vehicle that has a warhead at the front of it. And then in the very left of the screen there, you see an operator controlling that with a user interface. And right now, that requires a line of sight connection, RF connection. And then on the right, you see kind of the other side of it, you have an Iranian-made Shahed drone that the Russians are currently using. Similar setups, similar vulnerabilities. Next slide. So one of the big things here is then how do you get beyond line of sight communications where you don't have to have an operator in there, and also how do you build in more resilient communication pathways that aren't as susceptible to either ground infrastructure attacks or on the space side, attacks to the satellites themselves, and just resilient in general to the local jamming that's going on. So on the left, you'll see some of you may be very familiar with some of these satellite terminals that are located on top of a Navy ship deck. Extremely large, sucks a lot of power, very heavy. So how do you get stuff like this at the edge? And so that is what the commercial side's been able to do, is really reduce the size, weight, and power swap of some of these terminals while still providing extremely resilient communication pathways. So at the top terminal you'll see there is a Chimeta terminal. If you follow the little red line, you'll see there's an unmanned surface vessel that is currently being used by Ukrainian Special Operations Forces, and that exact same Chimeta terminal is sitting there on the back. That's able to reach different satellite constellations, to include those in low Earth orbit. And then on the bottom satellite you'll see there, it's actually the same one that I believe is up there on stage. Wenschel, if you could point it out, it's a Starlink flat high performance terminal. You'll see the same one on the back of another unmanned surface vessel. So what this really allows operational forces to do is to have this same resilient communication pathways, but in a much smaller form factor that they can get to the edge, especially on unmanned vessels like you see here. Next slide. So if you want to go ahead and start the video, let me know if you can still hear me over it. I'm not sure if it's going to make any noise. It doesn't need to, but you can see right now this is a user interface. I think it's showing the full motion video right now off the cameras on board. So there's an unmanned surface vessel there, and a user is about I believe 1,200 nautical miles away, tasking the system, setting waypoints, and telling it to go execute this autonomous mission. All this is being done over Starlink. So there's a Starlink flat high performance terminal, again the same one that you see up there on stage, that's integrated onto this unmanned surface vessel. So not only are the users tasking this system to go execute the mission, they're also watching the tracks of the system and also the full motion video. So another advantage to having some of these higher bandwidth solutions, being able to stream back either pictures or even full, high resolution full motion video, as you saw there, to for object detection, classification, and then even follow-on targeting. You saw the surface vessel itself right there, and then additionally, This is another asset we're using, a low probability of interception and detection satellite terminal. This one specifically reaches out to satellites in GEO, but just provides another solution to be able to integrate, and you can see it here on the unmanned surface vessel itself, but just providing multiple different resilient satellite communication pathways to control some of these unmanned systems. Yeah, boat itself, company there. So both of these companies, an advantage here at MPS is being able to establish collaborative research and development agreements, or CRADAs, with some of these companies. And we're just able to move a lot faster at an operationally relevant speed. So that's really the MPS goal here as a whole with this current research project, is making a direct impact to accelerating operational capabilities with the technology that's being used time now in conflicts around the world. So with that, while we're working to solve some of the communication problems here, there's also a lot of work still to be done on the PNT, our position, navigation, and timing side of it. And that's what Lieutenant Hansen is going to speak a little bit more about. So Forrest, I'll turn it over to you.
Cool, thanks, Austin. Good afternoon, I'm Lieutenant Forrest Hansen, also a Naval Special Warfare Officer. As Austin mentioned, my thesis research while I've been here is on alternative PNT, specifically using Starlink. So I'm going to talk a little bit about Russian GPS jamming in general, and then how that leads into my thesis. So up here on the screen, you'll see there's 3 different examples from before the conflict began and to this day of different examples of GPS jamming. From March to April of 2021, over 60% of the Organization for Security and Cooperation in Europe's UAVs were getting jammed along the Russia-Ukraine border. And also of note, that was corroborated with Hawkeye 360, which is a space-based data analytics company. So again, an example of how commercial data is able to corroborate on the ground truth. And then you see the second bullet there is the day before the invasion, Ukraine reported a jamming incident of one of their long-range UAVs, which is assessed that it was likely the TB2, which you see in the top right here. And then continually, the European Union Aviation Safety Administration is putting out these flight notifications to aircraft saying there's lots of jamming, as we saw with Dr. Lan's GPS jam image in that region. And then on the bottom right, that's one of the Russian EW assets, the Krashuka. So this leads into my thesis. Austin already did a good job talking about Starlink as a comms constellation and how those terminals are already being deployed throughout Ukraine. But lesser known is that in 2023, early this year, they announced that they're providing their own geolocation service to their terminals. And so that's if the terminals onboard GPS receivers are being jammed, the terminals still know where their position is based off of a geolocation method that comes from the Starlink constellation. So I saw this as an opportunity for alternative PNT for our US assets as well. In the top right, that's just a Starlink terminal. This is actually a Starlink advertisement on a search and rescue vehicle. And then the possibilities of, could we integrate this on UAVs and also on surface vessels as well? So what I decided to do was do some testing with both of these terminals that are in the front of the stage. I did static testing to see just how accurate these fixes could get and how long it took, and some basic parameters. And then also some mobility testing where I put the terminals on top of a car and drove around to see if they could maintain a fix while in motion. I also integrated it into some navigation software just to see kind of the usability and how challenging it would be to make this actually useful. And then I did some signal analysis to determine the detectability and if it's transmitting and receiving, and some basic characteristics like that. So here's some of the latitude and longitude results. In the image, you'll see top left is at 5 minutes, and then it has 5-minute intervals down to the bottom right, which is 20 minutes. At 5 minutes, not that accurate, spread out all over. And then by about the 10-minute mark, it gets a little bit more refined. And by 20 minutes, it's pretty accurate. So at the top, you see 25-meter longitude and latitude and longitude accuracy. And that's the circular error probable, meaning 50% of the fixes will be within that 25-meter threshold. And the average for that was 13.31 minutes. And throughout this, I want to highlight GPS is very good. And it's why there hasn't been much of a commercial market. You get a free, really good product. And so these numbers are not what we want to be seeing. But if you don't have GPS, this is a potential backup. So here are the altitude results. The blue vertical line, that's at the 5-minute mark, and then the gold line is at the 20-minute mark, with that red horizontal line being the terminal's true altitude. The altitude was a little bit different than the Latin long in that it didn't actually zero in on the true position of the terminal. It had this constant 31-meter error, which was a little bit unique. And then this is the mobile testing. It looks good on the picture because that's the GPS puck that was on board, which is the blue dots, but the actual terminals were unable to maintain a fix while in motion. If you look at the red dots, you can see they're sporadic and basically unable to track the motion. And that's both of these terminals up here. And then this is, it's called OpenCPN. It's an open source chart plotting software for maritime assets. And you'll see the bottom right, the real-time fix, that's what the terminal thought its position was, and that's indicated by the little boat there. And then the true terminal's position was just roughly 10 meters to the bottom left there. And this just took a pretty simple Python script to pull the data from the terminal and then write it to the correct port, and then the terminal was able, or the software was able to display it. Getting into a few more of the results. And I forgot to mention it earlier, but for the static testing, it was a 20-minute testing window. The terminal would power on, get a fix, refine that fix, and then once it was at the end of the 20-minute window, it'd record it and then start it over. And we did over 500 iterations of that, which resulted in about 2,500 fixes. And at the end of the 20-minute window, you get an average accuracy of about 7.6 meters or 17.6 meters. For the altitude, like I already mentioned, you get an average of about 31.43 meters, and that stayed consistent. And then we already talked latency. The reliability metric, that's at the end of the 20-minute window, about 80% of the fixes would be within a 25-meter radius. This is what I call this the operational testing, but there's a bunch of different tests. Of note for the Russia-Ukraine conflict is the jamming detection and detection categories. Based on prior research, based on just low Earth orbit satellites in general, as compared to where GPS is, which is in medium Earth orbit, a much higher orbit than the low Earth orbit satellites, you see a roughly 30 decibel increase, which results in about 1,000 times stronger signal strength. And what that translates to is a jammer has to have that much more power in order to overcome that signal. Additionally, these are electronically steered phased arrays, meaning that they're able to direct their transmit and receive energy in a specific direction. And if a jammer is outside of that direction, then it again requires more energy to jam these terminals. And one negative is, unlike GPS, which most GPS receivers are just a receive only, and that helps you in like MCON conditions where you're not allowed to transmit. These terminals do require constant transmission to stay connected. And one thing I want to highlight with these, this constellation was designed for communications. It wasn't designed for PNT. And that's why I think we see some of these hiccups. But in the future, there are constellations that are seeing a business opportunity in the PNT market. A lot of that is due to a decreased cost to get to orbit because of reusable rockets. So these proliferated low Earth orbit constellations are starting to have new business opportunities. So Zona Space Systems and TrustPoint are two companies that are looking to do PNT-specific constellations. And in the bottom here, this is a Zona advertisement, and they're advertising rapid, not sure what rapid is, but it's probably not 13 minutes, and less than 10 centimeter accuracy, which is pretty impressive. Both of them have demonstration satellites on orbit, but they do not have full constellations. And also advertising, of course, powerful and secure PNT capabilities. So the takeaway for this brief in this conflict is that these emerging P-LEO constellations are going to offer new capabilities for alternative PNT solutions. Like I mentioned, we've been relying on GPS for a long time. It's been a great capability, but a lot of our weapon systems, our platforms all depend on it. And the adversary knows this, and we've seen it in Russia and Ukraine, but also adversaries like China and Iran and North Korea all have GPS jamming capabilities. So these constellations are going to provide a level of resilience and robustness that we haven't been able to see. We haven't seen as we've relied solely on GPS. Yes.
Narrowing down that PNT granularity, right, that level of detail, is that a matter of transmission, power, total? What's getting us closer to?
Like refining.
Can you refine that question?
Yeah, the question is what's the limitation on refining that fix? Is it power or is it? I don't have a 100% answer because I'm speculating on the method that Starlink is using. But talking Starlink specifically, I believe it's their method of how they're doing it. They're likely using one satellite over a period of time versus using multiple satellites all at once, which is what one of these other constellations, in order to get a rapid fix, is probably going to do.
Starlink satellite PNT, does the data like derived from the GPS at a higher altitude or
So the question is, does the Starlink constellation require GPS for the satellites themselves in order to get that data down to the terminals? I'm pretty sure on this answer, but the answer is yes. The satellites themselves require GPS at this point. Although some of these companies are advertising that they're going to be able to get away from GPS, but at this point, Starlink satellites need their position from the GPS constellation. So what this alternative PNT solution can do is downlink jamming, in other words, jamming these terminals and jamming your GPS receivers. That's where this can help. But if the GPS satellites themselves are being jammed or unavailable, then this solution won't help with that situation.
I think a similar question. So the timing Starlink.
Yes, I believe so. And also my research, it honestly was focused on the P and the N, not so much the T. Cool. Any other questions? I'll pass to Dr. Lan. Yep.
I don't know if you went into it at all with your thesis. Are you testing any potential the ability for somebody to change the GPS location on receive?
No, I just looked at jamming. The question was, did I look at spoofing in addition to jamming? And the answer is no, I just looked at jamming in particular.
Is there any evidence at all this technology being shared with China, that threat, Russia, in terms of question?
Can you say it one more time?
Is there any evidence that China is either supplying or Russia is sharing with China GPS tracking?
I haven't looked into their relationship with each other, but both countries have very robust GPS jamming capabilities.
SpaceX spoke about improving the fidelity of the Starlink PNT or with software fixes?
So the last I've heard from Starlink was actually here at a Slam Time conference. And their main concern was that this is a communications constellation. So PNT is very much not a part of their business plan. So they haven't spoken about specifically refining this to become better, although I think they probably have the capability to do so. And perhaps with something like Star Shield, they may be more focused on that. But I think in the commercial market, it's just not something that they're that interested in. I'll pass it over to Dr. Lane.
Okay, so just to kind of summarize the lessons learned and the takeaways from this conflict and how commercial space is used. The first one being that there's just data that's available to countries that don't have space capabilities, right? And it's unclassified. So that's a big game changer. The second being that commercial space provides resiliency and then in turn deterrence. And then and it's not just with imagery or communications, it's also PNT, like Forrest just talked about, with launch. So it's across the entire space industry. And then lastly, we recognize that vulnerabilities exist and they always will. But despite those vulnerabilities and the discussions surrounding that, commercial space still stands to provide that asymmetric advantage in strategic competition. So with that, I guess we'll open it up for general questions, but thanks for coming.
So since it is all on the unclassified level, and to integrate and be able to use this, our current information networks, we'd have to be classified? Do we have to wait for SDA and Starshield to get up and running? Or is there a way to do classified level information? Starlink constellation?
So I can.
Okay, thank you.
Hi, Jerry Thomason, also with Space Systems Academic Group. I run the Slam Time conferences, bring the commercial industry folks together here at MPS.
Hold on, if you will.
So the specific answer is that the Navy service has a responsibility for terminals and also for PNT. So the Navy component that's responsible for that is within Naval War is PMW 170. PMW 170 has a program called STING, and that program allows for Starlink in particular to have a connection to the ADNS on a ship. And you can route through an unclassified network, through a black network, through VPNing, and tunnel through the unclassified network to provide communications and also some of these PNT capabilities. Does that answer your question?
It does. Thank you.
Okay.
Thanks for the assist, Grinch. Any other questions? Yeah, John.
First, great presentation. It's really good.
Thanks.
Way better than the last one.
So what do you think this says about the frequently heard proclamation about being able to hide in plain sight at sea?
Austin, do you want to take that one or?
Sure.
Okay, thanks.
Sure. Yeah. So it's a great question. So I mentioned, my previous operational experience in this theater in particular. So one thing that happened that I think sheds a lot of light on this was we gave the Ukrainians, we being the United States, gave the Ukrainians several hundred military radios, traditional military radios with MilSatcom. Those were immediately used as dummies because within about 2 minutes there were mortars on their head the second they turned those comms on. So they ended up actually just strapping those things to trees and then using that to find the mortar positions, to triangulate the mortar positions. So they were great decoys, and that was about it. So the same thing, a lot of the same stuff applies here. Is what's currently being used is the idea of obfuscation, or kind of hiding in plain sight, as you're getting at. This has a lot of implications in the maritime domain, especially in the Pacific theater, when you start to see, and this is where the blend of both commercial and military purposes starts to happen, where you have lots of fishing fleets, you have lots of civilians that didn't otherwise have connection, and especially not high-speed internet access, start to use these systems. So that becomes a lot of the RF spectrum in a given area. And then you don't really know if a naval vessel, if an unmanned surface vessel, if something else is using is producing a similar signal on the electromagnetic spectrum. You really don't know if it's a civilian, if it's a fishing boat, if it's a naval vessel, or what that is. And that's the same thing that's happened in Ukraine, where they've passed that out to civilians that lost, because of the infrastructure damage, lost internet access or connectivity at all. It was mainly used just for civilian purposes, right? Just to provide internet access to the populace to continue work, to get the latest news, for evacuation, for whatever else. But then the military is also using those similar signals. So really that boils down for obfuscation and then just kind of hiding within that RF spectrum. Hopefully that answers your question.
Yep. Captain Hammer is nodding up and down. So Randy Pugh here again, and asking Wenschel to share the website that I brought up. Find it. Where'd it go? Yeah. There it is. Yeah. So if you haven't seen this before, this is pretty cool, and it's been around for several years. It's called SpyMeSat. And you basically, it's on your phone as well. You can download the app. It'll geolocate you down to GPS, grid coordinates, whatever it is. And then it lays out for you every single commercial satellite provider that has a satellite that is, the orbit and the track of the images that it can take. And then you can basically pick the location you would like a picture of. It will and the resolution you would like. And then it will tell you the different providers that provide it, and it will give you a quote for the amounts that you would have to pay for it. You click on buy, and when you click on buy, it will take the image as soon as it's able to take it. And then it will email you a thumbnail sketch of the image. And then, when you're ready and you have, you're not on the cell network, you get home to your Wi-Fi, you can download the, 4 megabyte, 6 megabyte version of that picture. And so, the question when Wenschel was providing her brief, like that, conceptually that's cool. Like governments that don't have any space capabilities can get, exquisite imagery. Joe, anybody can get exquisite imagery. And how would you do it? You go to SpyMeSat, set up an account, link it to your credit card, and you can buy it. And then just one other comment, because I spent some quality time in Kabul at the ISAF SOF headquarters. A lot of that job was trading intel back and forth, like providing intel to disadvantaged partners. And what can America provide that you don't have in order for you to be fully mission capable to go out and do special operations. And a lot of that was based on intel, and a lot of that was based on imagery. And this gives you the ability to instantly share with partners at the unclassified level. Pretty good, and almost always good enough for what they needed. And so at the time, this was 2009, U.S. government had an open account at these companies for several $1 million, and you could just charge against that John or a job order number in order to buy imagery to provide to your partner forces. So the future, it was in 2009, and now it's today. So thanks. Any other thoughts on that, Wenschel, from you or Space Systems Academic Group on where? I guess my question would be, that's EO color imagery. So my first question, and then I'll stop. I get two. One is, where else can you go to get this commercial imagery besides SpyMeSat, because that's the only one I know of? And then the other question is, are there other phenomenologies? So EO, IR, SAR, all the other kinds of imagery that the intelligence community provides. Are commercial companies also providing that?
Well, answer the second question first, and I'll hand it back to Grinch to answer the first part. So you might want to pass the mic back to him. But so for the second part, yeah, there's other types of imagery. It's not just EO in the visible region. There's IR, there's synthetic aperture radar, and that's what Capella Space and I believe Hawkeye 360 are doing. So there's a lot of companies that we didn't even mention. These were just like the ones that we highlighted. But yeah, there's definitely a lot of different types of remote sensing products out there. And then Grinch, if you want to answer the first part as to whether or not it's available in other places.
Yeah, sure. And thank you, Randy, for bringing up the commercial capabilities, because anybody with a CAT call card, every single one of you currently have access to commercial data that is shareable. And it's through a program I just pulled up on my phone. You can Google search it, CAC-enabled satellite imagery. You can Google it, and it'll bring you to the website that used to be owned by Maxar, Global Enhanced GeoInt Delivery. And that is a very excellent site. You can pull down current imagery from just an hour or two ago. And you have it on screen right there. Beautiful. It's almost like we choreographed that.
Thanks, Grinch. Randy, does that answer your question?
Yeah, even better. Yeah.
Okay, thanks. Are there any other questions or comments?
Probably outside of the scope of this, but it kind of begs the question for me of the freebooter nature of these commercial satellite phenomena or systems or what have you, because I can't help. I'm stuck as a historian and looking at things like Cortez and Pizarro going for their own gain. Okay, I'm going to bring the flag along with me or whatever, but I'm really going out as a freebooter. And in that regard, even though you touched on that briefly in your portion, that generally we're not seeing adversaries decide to knock these satellites out. I'm kind of curious as to how long, and it's unknowable at this point, but how long that will be the case, as this is critical battle space information.
Yeah, and when we were preparing for this brief, we had this conversation multiple times. Like, if you had an adversary satellite taking images over your head while you're in an active conflict with them, like, it seems like a viable target to me. So yeah, we don't have a great answer for how long it'll be until these targets start getting, kinetically targeted. Obviously, already they're very targeted in terms of cyber and EW, but we have yet to see like large-scale kinetic attacks, because that's obviously a much higher escalation compared to the EW cyber stuff.
Thanks so
Hey,
much.
Forrest, if I can jump in here, it's Austin again. I think you bring up whoever the gentleman is that asked that question. You bring up a great point, and I think the answer is actually not very long. And we saw this happen already really fastly, as Wenschel mentioned with Starlink. And then the company itself started to pivot, right, and change their business model into both a commercially owned satellite constellation and a separate government-owned satellite constellation, now being called Starshield. So you see on the company side, as they start to assume risk, right, with no risk to the government and full risk on the company themselves, they start to have to pivot as they become viable military targets and shift their business models. So there's the aspect of the companies themselves having to think about that, but also I think there's a separate conversation on the government side, our responsibility to, if we want to keep these commercial systems in place, using them responsibly and making sure that they're around for the long haul, right? And that those dual use purposes can stay in place. And so, yeah, maybe using just straight up commercial communication constellations for offensive purposes is not the move. But there's definitely some advantages and ways that we can work around that, as we're seeing with Starlink and Starshield. So hopefully that addresses that a little bit. Over.
Very good. Thanks. So thank you, Austin and Forrest and Wenschel, for a fantastic presentation. Really appreciate it, which is both, the technology, the military use of it, and then also looking at what's being done and looking to the future. So that was perfectly done. Thank you. Just administration, the 11th of January is going to be questioning the carrier Seapower conversation. And then we're going to have a Seapower conversation on the 23rd of January, which is the USS Carney and the shoot down of ballistic missiles and drones in the Red Sea. And then the electronic warfare one, and the last one for this series will be the 7th of February. So thank you, everybody, for your great questions and your attention, and thanks to the presentation group. Have a great afternoon.